And to be more than happy to get your feedback later. If any point, for example, need to be modified, or you can see that this one actually not going to be necessary enough, we may not consider your all your comments, but in general, I'll try to take the most important one and apply it to the marking criteria. So you can see that the marking criteria here is going to be out of 60. And the other 40%, 40 marks is going to be for the oral presentation we're going to have. The oral presentation can be pre-done. I mean that you join together, a meeting online as a group. You are going to make your own presentation, something like you have the team meeting, and you're going to add your comment on your part. So every student, of course, is going to have a different section on this report, and you are going to talk about your section in the presentation. The presentation should have something between 6 to 10 minutes maximum. During these 6 to 10 minutes, you are going to talk about your different designs, show us some handy sketches, the final design which is made by the CAD model, give the advantage and disadvantage of this model over the others. Basically talk about briefly about the manufacturing process of every part we have for the pump, and link it to your report. Now we go into the report, which is going to carry the 40%. We're going to have 7 marks for the reported presentation. When I said report presentation, it doesn't mean you have to do a presentation, but how the report was delivered. We're talking about the appearing. Okay, so we're talking about the present of the introduction, the description of the target of the product and its application. The introduction is going to be the first part. This one is going to be 2 marks. We expect to have the brief background of the product, the state of the art of the different technology we have for different pumps, the goal of the recent project. Everything you have here can be actually be similar to the document I shared with you for the hand pump. Why are we doing that? Okay, what is the pump? What are the different models we have in general? You can talk about 2 or 3 types. You can use the same references I shared with you. Now, the report general format and the quality. The contents are, again, must be well presented and easy to follow up, and the reasonable use of the images and the flow chart. So I don't want to have a dry report. I don't want to have unreasonable use of the images and the flow charts. For the research and referencing, you are going to have 2 marks. You should have the information that should be relevant to the topic, consistent font and size, and the graphs, the image, and the tables should be properly captioned. And also the information should be properly cited. Engineering knowledge. This will carry 3 marks. The proper analysis of the product components, the function and the working condition of each component are described, the justification of the required accuracy and the service integrity, and you can refer to a standard if applicable. Actually, I shared one of the standards with you earlier, and I'm going to reshare it soon, which is going to be about the Australian standard for manufacturing. I'm going to share this one with you soon. This will be 3 marks for the engineering knowledge. Show us that you actually know what you're talking about. Diagrams, like the engineering drawings, is going to carry 2 marks. Engineering drawings with the main dimensions and the surface integrity. Referring the standards if applicable. Actually, when you're going to make the CAD model, it's going to be very easy to make the engineering drawing for the part. The material selection is going to have 7 marks. Now, you will say, why we have this heavyweight for the material selection? Because that means you understand what are the properties of every different materials and what the effect of this material on the manufacturing process and the performance of the part you're making. So the material selection and justification For example, you need to look at the impact of the materials on the product's component's life and or performance. What materials may be selected for each component and why? Are there any alternatives? The advantage and disadvantage of these materials, the material selection effects on the manufacturing processes selection, the material selection effects on the energy required for the manufacturing, and finally the effects of the material selection on the recyclability. Now, when we talk about these points, of course, if I'm going to use, let's say I'm going to use steel, and I'm going to use this one to pump the water. The steel is going to be highly affected to the water, so it's going to be for example, it's going to get rusty. The aluminum is going to be more resistance. Stainless steel is going to be the best. These are some of the examples. Of course, going to have higher strength for the stainless steel, but this will increase the cost. We're talking about the selection on manufacturing processes. Harder materials is going to be harder to machine. We have to repeat each of these sections of each course. No. Actually, I'll talk about this one soon. Just give me 1 second, Liam. Just remind me after we're finishing this one, okay? This will be only for the final design you adopted. So you are going to have 2 or 3 different designs, and you will go with this one of these designs. You'll say, okay, now this will be my major design, and then you're going to do everything here for this design only. Is that clear?
Yep, that makes sense.
Okay, so material on manufacturing processes. Some of the materials are going to be strong, well, high strength. That means it's going to require different manufacturing processes. Of course, manufacturing of the plastic is going to be different from manufacturing of the steel, different from manufacturing of aluminum, and so on. The material selection effects on the energy required for the manufacturing. If again, just an example, if I get to have, for example, make the whole body out of steel, again to have different technology than the one if I get to use the plastic, because the energy required to make the plastic by the extrusion process is going to be less than the process of making the steel bar or the cast iron bar by the casting operation. The effects of the material on this we're using for the selection for the recyclability. If I get to use the steel or using the aluminum, I can recycle it. The plastic usually recycling is going to be less possible, especially if you're going to run for a long time, and the property of the plastic is going to be changed within the time. You can search about that. Now, the part of the engineering processes and the DFX, this will carry the 1/3 of the total mark of this report. First, design for manufacturing. You should discuss the proposed manufacturing processes, operations, and pre-flow chart. The flow chart can be, actually, it's going to be done here as a route sheet. So it's up to you to make a route sheet. The route sheet must be done, but it's up to you to add the flow chart. If you would like to understand how the flow chart is going to be look like, you remember the flow chart we used for the casting for the engineering block in the assignment number 1? That's the flow chart. Like, for example, take the pipe, cut it to a length, do the drilling operation, and then you are going to assemble it. So you can do that by multiple blocks going in by using the arrow to one direction. Details description of the proposed processes or operations. Required manufacturing equipment. What do you need for the drilling tool, right? The drilling machine. Are there any alternative manufacturing process or operation? What are their advantages and disadvantages? Also, the manufacturing processes or operation suitability for the selected material, the manufacturing processes, operation, and the product component cost, the manufacturing processes or operation on the environment, the manufacturing process or operation impact on the product component specifications. The design for the assembly and de-assembly. Just remember that everything we mentioned here, I already covered in the tutorial I posted 2 weeks ago. You can always refer to it. And if you still have more questions about that, you can come back to me and I'm going to be more than happy to answer your questions or have another session. Actually, sorry, I meant to have a session on Friday, but some of the students didn't want it. How detailed should be the route sheet? It shouldn't be too extended. What is the state of the art? Okay, now state of the art is, for example, I will talk about the laptops. Okay, then I will start at the big. I will talk about the state of the art. Now, for example, I will say that we have the computers, which can the laptops can be divided to a window laptop, which can be divided. The other type is going to be the Macintosh, and we have the the other type, the one that's using different programming language,
like Linux.
Like Linux, yeah. So the different types that are available nowadays, which one is the best one from your point of view? Yeah, thank you very much. Which one is what are the advantage of the Macintosh over the of the Windows and so on? So that's what we call the state of the art. What are the available models nowadays done by the Engineers Without Borders or the water pumping organization and so on? Just show us different models. Just show me that you made a search and you found out what are the different types available. That's what we call the state of the art. Okay, so design for the assembly and the assembly, because we mentioned earlier that actually you can find a lot about this one in the assignment sheet. It's about the time required for the assembly of the product and the time required to deassemble the product at the end of life. Because this time, the first one for the assembly is going to be an addition cost of the products. For the de-assembly, is going to be addition cost of the recycling process. I mentioned once again that when you go to junkyard, you can find many cars, refrigerators, TVs, computers that were not actually being de-assembled because it's required to have some extra time. That's going to cost you a lot than the components of these devices to be spent to de-assemble the parts. So you need to discuss that. For the pump, of course, going to be something different. And once again, the sheet for the project can explain a lot. Design for the recycling, you only need to classify the parts of the product, which is the pump, into recyclable components, non-recyclable components, and reusable components. You will say for the shaft is going to be made from the aluminum, is going to be recyclable. The body of the pump, which is made of the plastic, you can say that this one is going to be recyclable. It is going to have still maintain the same properties. Simply, this can be inspected. How do you inspect the PVC material is going to have the same property or it has been damaged? Do you have an idea on that? Usually hold the tube, you press it by your hand. If it's going to be cracked, that means it's lost its properties. That's easy. Okay, and for example, for the valves, mainly can be reusable. Okay, and the same thing is going to be for the T-junction we have for the pump, if you're going to use the standard pump. The T-junction can be reusable. Most of the components which are not going to have change in their properties or change in their change the property due to the life or the of the operation, this can be reused later. And actually, using the reusable is going to be a very good thing, because this is not going to require any energy to be used for altering shape or changing the material from one part to make another. Design for the cost, which is going to be just an estimation manufacturing cost, like the time required to assemble or manufacturing each part, labor cost, and the equipment. This can be an estimation. You can make a table for making one part, which is going to be the prototype you are making, and what will be the cost you're going to make 100,000 parts. Because once again, I talked about the different technology can be used for manufacturing, can vary the cost of the manufacturing as well. The route sheet. Route sheet is describing all the manufacturing processes for every components must be provided, even the standard items like the nuts. I can give you an example of the route sheet. Okay, I can give you an example of the route sheet. I will post it very soon. So the route sheet is, you know, the table we had for the sand casting. Instead of make it as a block, you can write it down. Like you will say, prepare the sand, check all the properties. Then you prepare the pattern, you prepare the box, put the box on the first half, make the cavity for the cob and the drag, put the two halves of the mold together, prepare the down spur, mold the metal, put it at this temperature, which is going to be the pouring temperature, start to pour the metal slowly. So you just describe the process. Why we're using the route sheet? Usually when you are going to be a designer or engineer, production engineer, you're not going to perform the work yourself. You are going to write down all the details. Actually, it's going to be, it should be very specified. You send it to the worker, to the workshop. They always going to try to annoy you by telling you, oh, we didn't get that. What do you mean? So try to cover everything in your route sheet. However, the route sheet required for this report, it doesn't have to be a professional one. Just try to make the sequence description of the manufacturing process as point 1, 2, 3, 4 until we're going to have the finished part. The route sheet describing the assembly steps also going to be provided, and this will carry 3 marks. Now, the route sheet for the assembly is going to be which part to be joined to the other part first. So 1 to 2. Then the assembly is going to be added to the part number 3 to have the other 3 assemblies. So which parts we are going to add together? This simply can be done by the exploding image of your CAD model. Then you can see actually what will be the logic sequence of assembling your pump. Number 6, and this is very important. Actually, these 2 parts are very important. The first one is going to be logic and judgment. This will be the judgment of the marker on your judgment. So the project report adopted a logical sequence, like the manufacturing processes, the manufacturability and the standardization, the accurate judgment of the technology adoption and the material selection, the coherent design was presented, the quality assurance and the inspection was applied. Project management, 8 marks. Now you'll say why we have to have 8 marks for the project management, because I would like to encourage you to work in groups. You need to have an evidence of your collaboration. A meeting and discussion event logbook should be added at the end of your report. And this again to be simply like 1 page. Today, the 27th of September, 2021, 5 p.m., we had a meeting for 15 minutes. We discussed 1, 2, 3. That's it. Next day, the 1st of October, we met for 30 minutes. We discussed 1, 2, 3. You don't have to mention what you got as a result. Just tell me what did you discuss, what time, and how long. And also we have the task assigned to the group members. 3 people. What did every student done? The workload distribution, the student individual impression, just something like 1 paragraph. What did you like? What did you learn? What's this all going to actually, what you're going to improve yourself to do better if you're going to have the same assignment again. The example, Yani, all the example we're talking about regarding the route sheets, the logbook. Also, I tried to find one. And who asked me another question? No. Well, actually, you can give a brief about that. For example, if you're going to use a screw, usually how the screw is made. You remember that? The rolling thread. Lucas? just to show that the student actually have an aware about what we described in the subject area. Because almost all the parts that we are going to use, even the off-shelf items, are described in this subject, including the making of the plastic materials going to be covered very soon. Thank you very much. Okay, what else? Yep, we're going to this part. Okay, now let's add, adding up the marks is going to be out of 60, and the 40% is going to be for the presentation. I will show you the marking sheet for the presentation next week. And again, if you have any questions, actually, I was happy to run an extra session last Friday, but I think that some of the students didn't prefer to talk on Friday. So will we do the Spark Plus for this subject? No, just keep it as it is. Dalita. We're going to be doing the traditional way. Okay, so if in case you need to have a session to discuss anything that's not actually still unclear to you for this project, we can meet later. Anytime. I think that Friday is going to be good with me. Thursday is also going to be good with me, but it will depend on your time. This week I will post the second part of the major project. I think that I would like to make it live. I mean, we're going to meet together and we're going to talk about the major project live, because most of the video I'm making, the student doesn't watch it until the last day of the due date, and I usually try to avoid having that. Usually the last minute is not going to be the good time to finalize the thing. Okay, now why you need the Spark Plus? Do you want to say something that your colleague not doing? Just tell me directly. I know. This is the only time we have, but we all, well, as I told you, I always going to be more than happy to run an extra session for you, Callum. So I can even do it in multiple sessions if the time not going to be suitable for you at the time slot A, we can do it for another time that suits you. So you remember when we were doing the polling, when I said, okay, now what time is going to be the most suitable for you? We can do the same thing. If you have a question, just jump in, ask this question, or you can watch the recording later. But usually watching the recording is going to be something boring. When you're going to be live, you will listen, you will understand, you will ask a question immediately, instead of watching the video and looking for a question similar to yours and try to find it and understand it. Anyway, once again, it's up to you. I know that you are busy. Most of you have 3 or 4 subjects and working at the same time. But honestly, let me tell you that I also, everything I'm doing for you, it's also an extra work on me. I'm doing that because I care about you. That's it. Okay, so I care about your learning, your actually the standard you're going to have from this subject is very important for me. Thank you very much, man. Okay, so I don't want to keep you a lot. I know this is the first Monday of the semester and it's too boring. Next week, we're not going to have a lecture. I'm going to make a video and send it to you. For the different design, do we select the different existing design? Yeah, it's up to you. Yeah. Okay, so I expect that you are going to have a certain amount of the innovation. It doesn't have to be something brand new that nobody done before. But for example, you are going to use the idea I put on the paper earlier, using the multiple ball valves, like you remember the barrels, the barrel one with the piston at the top here. This can be a good design if you're going to change the valve instead of being the one with the flipper. you can have the ball valve. Okay, many ideas are possible. Just try to put your own touch, try to modify any design and say, okay, now this is our design. That's what we're going to do. And you can mention that, what did you modify exactly? Okay, and this will be an innovation. I don't expect you to have a new design by 100%. I cannot do it. Maybe if we're going to work all together, we can have a new design, and this need to be patented later. Okay, now again, to start the recording for this section, and we're going to talk finally about the grouping.